Hi, this is Mark, and I'm going to show you a little bit of 2019 Set 1 AP Physics C Electricity and Magnetism Free Response Question 2, which has this circuit. The question says, the circuit shown above is constructed with two 6-volt batteries and 3 resistors with the values shown. The currents I1, I2, and I3 in each branch of the circuit are indicated. Using Kirchhoff's rules, write, but do not solve, equations that can be used to solve for the current in each resistor. Well, they've given us the currents, but I drew 2 red loops on there to get myself started thinking about this. I'll write the junction rule equation first. And that is easy because they've given us the currents already. And it turns out when you solve this, those are the correct currents. I1 plus I3 equals I2. They're correct in that the directions are correct. When the currents are incorrect, you get a sign error. You get a negative current, and you have to figure out what went wrong. But since these are the correct currents, the students who follow the solution process correctly won't get a sign error. And then let's write our Kirchhoff's voltage rule equations. There are 3 loops you could write. This first loop, the left loop, clockwise. Second loop, the right loop, counterclockwise, and then the outside loop, which you could do either clockwise or counterclockwise. So for the first one, the left loop, 6 volts minus 150 I1 minus 200 I2 equals 0. I usually leave off the units because the equations are a little bit complicated and they get harder to read with the units on there. The right loop, 6 minus 100 I3 minus 200 I2 equals 0. If you look at those 2 equations, there's something interesting there that you may notice that's useful when solving the problem. I'll come back to that a little later. The third equation for the outside loop, I'll do clockwise again. 6 minus 150 I1. Notice we're going the opposite direction across the 100 ohm resistor. The current goes left and I'm going right. So instead of being a potential difference drop, that's a rise. So plus 100 I3. And then I'm going the opposite direction across that battery. So instead of being a potential difference rise, it's a drop. Minus 6 equals 0. So there's part A1. I've written one more equation than I really need, I think, but that should be a correct solution. So now here's the interesting thing to notice. These 2 values must be the same thing because the rest of the equation is the same. Look at the third equation. 6 minus 6 is 0. Negative 150 I1 plus 100 I3 equals 0. That leads to the same conclusion. 150 I1 equals 100 I3. So part A2 says calculate the current. Well, I've noticed this fact, so let's work with that. 150 I1 equals 100 I3. So that's 3/2 I1 equals I3, or 2/3 I3 equals I1. Let's look at equation 2. Now I've found this relation between I3 and I1. I'm trying to find current I2. I'm going to go back to my junction rule equation and substitute in 2/3 I3 for I1. And then I'll just have an equation that relates I3 and I2. And I can use that in this equation to solve for I2. So 2/3 I3 equals I1. That means that 2/3 I3 plus I3 equals I2. 5/3 I3 equals I2. or 3/5 I2 equals I3. So equation 2, 6 minus 3/5 times 100 times I2 minus 200 I2 equals 0. So 300/5 is 60. So we have 6 minus 260 I2 equals 0. So 6 volts equals 260 I2. Therefore, I2 equals 6 volts over 260 ohms. And that gives us the answer of 23 thousandths amp, which is the correct answer. It's a little bit of mathematical complication here, more so than most even AP Physics C circuit problems, but it is a relatively doable Kirchhoff's law question. Thanks for watching. Remember, what one fool can understand, another can.